Now that we have understood the algorithm behind merge sorting algorithm and we have already implemented the utility function that we would be using while writing the merge sorting algorithm, let's go ahead and let's write the merge sorting algorithm implementation using C++ here in our project. So for that, inside this coding.pal CPP DSA project, inside the sorting folder that I'm keeping track for all the sorting related implementations, I will create a new file called mergesort.cpp. Okay, here in this file I'll be writing the entire merge sorting related specific implementation here. First of all, let me just bring in the boilerplate code here, and after that let's just include the vector as well. Okay, once we have these two, what we need to do, we will create our own class called merge sort. Okay, here what we will do, we will write one public method which will basically take the array of values. In the end it will return the same array of values which are sorted in the ascending order. As a result, the definition of the function will be, the return type will be vector of type int, and let's name the function as merge sorting. And what it does, it needs to take the same array of values, right? Let's just assume that it is taking in the variable arr, like you see on the screen. Now, if you remember the algorithm and pseudocode that we have written clearly, right? As part of the merge sorting algorithm, what we will do, we will try to divide the array into two halves till we reach a point where we have only one element left in that divided array. Okay. Otherwise, if at all, if the array that we are getting is having more than one value, again we will try to divide it to a point where we have only one element left in the array. For that, since we are going to implement this function recursively, what I will do is, as part of the base check, I will check if the array that I'm getting in the function call is having only one value. If so, the element with one value it itself is sorted, right? So we can return that array itself. So for that, what I will do is, in the base condition, if the size of the array that I'm getting is equal to 1, that means that we have divided the array to a point where we have only one value left in it. So since it itself is sorted, we can simply return the array itself. Okay, if this is not the case, that means whatever the array of values that we are getting, right, in this array of values we have more than one value. So our immediate step is to divide the array into two halves, right? For that, first what we need to do, we need to calculate the middle index, so that from 0th index till the middle index minus 1 we can divide it into one part. From middle index till the very last index, whatever we have in the array of values, we can divide it into the two parts, namely left half and right half, so that we can again try to sort the left part of the array and try to sort the right part of the array. In the end we can merge these two sorted arrays such that our we basically get the increased sized array in which all the elements are sorted. For that, first anyway, let's just try to calculate the middle. So middle is nothing but the size of the array divided by 2. Okay, once we calculate the middle, right, we need to divide the array into two parts and call the same merge sorting function recursively. For that, what I will do is, I will simply try to create another vector. Let me just name this as left array. In this, we need to have the values from this array from 0th index till this middle index minus 1th position. For that, what I will do is, to automatically copy the values from this array directly, what I will do is array dot begin plus I need to start from the 0th index till middle index minus 1th position. To copy till middle index minus 1th position, what we will do is, we will just pass the middle index itself. So array dot begin plus middle index. So ideally what it does is, it copies the values from 0th index till middle index minus 1th position. Okay, similarly for the right part of the array, what I need to do, let me just name this as right array. Okay, for the right array, the starting value will be starting from the middle index till the very last value. So for that, here instead of starting from 0, what I will do is, I want to start from middle value and I need to end at the very last value, which is nothing but array dot size. So it copies the values from middle index to array of size -1, which is nothing but the valid last index in the array. Now what we need to do, we just need to call the merge sorting algorithm with left array and right array, and in the end whatever the sorted arrays that we will be getting, we need to merge them. So for calling that function recursively, what I will do is I will call this dot merge sorting of, I will pass left array. Okay, after sorting whatever the array of values that we will be getting, right, they are obviously sorted. That's the reason why I will simply try to store it in another variable. Let's just say let's just name it as sorted left array. Okay, similarly for the right part of the array, what we will do, we will call the same function recursively, but we will pass the right array, and let's just name the resulting array which is sorted as resulted right array. Now since these two left and right sorted, sorted left array and sorted right array are already sorted, right? In the previous step we have already implemented one utility function called merge two sorted arrays, right? We can simply call that function by passing these two arrays such that whatever the resulting array that we get, in which these two arrays will be merged, and we will get the result also in the sorted fashion. For that, what I will do is, since we have already implemented this function, I will simply copy paste this function in the merge sort file. So here let me just add that function. I've just copied and pasted, that's it. There is no change at all. Now all we need to do is we need to call this function from the merge sorting function. So let's just call this dot merge two sorted arrays. First value is sorted left array, and the second part is sorted right array. Okay, all we need to do is we need to return this merged sorted array in the end. Okay, so that's all there is with respect to implementing the merge sorting algorithm. Remember that it is a divide and conquer based sorting algorithm. For that, what we will do is we will divide the entire array into two halves till we reach a point where we have only one element left in the array, because when we have only one element in the array itself is sorted. So as a result, we will divide the array and we will call the same merge sorting function. In the end, whatever the result that we are getting, we are merging it by using the previously implemented merge two sorted arrays function. As a result, in the end, once the call stack is cleared in the recursive calls, we will basically get the entire array sorted in the ascending order. Okay, so that is the merge sorting implementation. Now let's just try to call this function and validate if it is actually able to sort the given array of values in the ascending order or not. So here let me just create a vector of int array equal to, let's just say the values that I want to sort are 12, -20, -12, 3, 1, 0, let's just say 129. These are the values that I want to sort in the ascending order. Now let's just create the merge sort object, and using the merge sort object, let's just call the merge sorting function, and let's just pass the array of values that we have created. Okay, and it will basically return the sorted array in the end, right? So here let's just name it as result array. Just to confirm whether it is sorted successfully or not, we would want to print the values, right? For that, let me just run a loop I less than result array dot size I plus plus, and let's just do C out of result array, my bad, I'm just result array of I, and once we are done printing this, let's just print some space, and after the for loop is ended, let's just add the end line here. Okay, now let's just simply run it. So right click, choose run code option. If we see the output that we would be getting here, we've got some issues here. could not search. Okay, here I need to give this one. I gave, let me just read, and one more thing here as well. Okay, that is the issue. Now if I run it, see, if you look at the values that we have got on the console, the output that we have got is -20, -12, 0, 1, 3, 12, 129, which are sorted in the ascending order. If you look at here, how many values we have? 3, 6, 7. In the output also we have got 7 values. Okay, if at all if you want to add any other values, 0, 1, even you can add any duplicates as well. Even if you add the duplicates, ideally the program should sort the values in the ascending order only. Let's validate that anyway. So if I run that now, see, all the duplicates are also anyway adjacent to each other. Okay, so this basically completes the merge sorting implementation. In the next videos, we will move on to one more divide and conquer based sorting algorithm, which is quick sorting algorithm. Okay, thanks for watching this one. I'll see you in the quick sorting discussions.